Welcome back, ladies and gentlemen, and now let's see how we can handle missing data and how we can also know the first n and last n elements of a row of a given data, or rather how to know the first n rows and the last n rows of a given data frame. So let's go to our environment where we are doing our Python code. So first, what I will do, let me go away with this other code and print out. So here we want to use this Excel workbook to deal with the n element. So first, before I print out, let me just let me run the code without printing anything. So here we have the code reading an Excel. So again, let me try to print df here. Print df. So when you check this data frame called df, there is no missing data. All the cells have values. There is no missing data in the sense that you don't have any cell written none, mean not a number, or null values. But when we go to our Excel frame, so here I want to print the Excel data frame, and then I will comment out this other one. So you can see we have a data frame here with the sub-ledger column having null values. So there's there are cases where you'll want to do away with the rows that have null values, or do away with the columns that have null values, or just delete the columns or rows with a certain number of null values. But in our case here, I want to show you how to delete columns where we have null values, and rows where we have null values. So what we'll do here, we'll come down here and say f1 is equal to df1 dot drop now. So here let me just say dropping rows with null value. So here we are dropping any row that has a null value has to be dropped. Either the row just has one null value, but the other columns we have other cells, there are some values that you just want to drop if the row has a null value. So we'll come down and say df1 is equal to df1 dot drop. So we write drop now. So drop now to mean we are dropping the null values. So down here we'll come down here and print df1. So remember how we said that variables can change from time to time. So now the printout that was up here is different. With the same data frame, but the values will have changed when we drop the null value. So let me just print this. I will print that code. Let me create a space in between. So here print then now let's run the code, see what happens. So on the first code, you can see we had null values. Okay, we had then none. From this row, you can see row 3, row 2, row 3, and row 4. We have the null values, and some have been hidden because the rows are so many. We have 1974 rows with 10 columns, and then you come down here, you can see now we have now we don't have the null values that we are having in row 3, row 2, row 3, and row 4. And then the number of rows now are 1695 as opposed to 1974. So we've deleted quite a number of rows that were having null values. So here we'll only deal with the data frame that has values in every cell. So that's how to delete rows with null values. Again, let's see how we can delete rows with so dropping rows. It's now not dropping rows but dropping columns with dropping columns with columns with null values. So when we drop with null values, we must say that the axis is equal to axis has to be 1 because we are dealing with the column. And again, the first one we are supposed to write axis is equal to 0 because we are dealing with the rows. But by default, when you don't write the axis is equal to 0, the code will only be dealing with the rows as opposed to dealing with the columns. So here again, we'll say drop now. Axis is equal to 1. Then we want to run the df1. Now let me comment out this other Python code for the rows. Just want to print this other one for the columns. So let's run the code again. So the subledger is still there. Now axis is equal to 1. We still have none, but we have 7 rows. Okay. So drop now is only picking, I think is picking where the null values are numerical values as opposed to being text values. So for example, in this case, initially we had you can see the F1 we had 10 columns, but after dropping the columns with the null values, now we have 7 columns. So we only had 3 columns with null values, but those are the columns that had been dropped. But those columns were having numerical values, not text values. So the text values will not be considered when we are dropping the null values. So that's why you are still seeing NaN. Or rather, I'm not saying the correct thing. So the null values are being dropped. So we've dropped 3 rows. The 3 rows that we've dropped the subledger. This was the original data frame was having this subledger with null values. So another subledger, rather another column was also having null values, other 2 columns. So the 2 columns have been dropped. So now you can see we have 7 columns as opposed to 10 columns, and then the rows are now the same. The rows are 1974, but now we've only reduced the number of the number of columns. But now again, when you are to drop again also the number of rows. So here now again, let me try to uncomment out this. Again here we'll write down here print in bracket df1 . Now here I want to print a blank, not df1, so this one is a blank space. So now you can see here it's the same data frame, but now this one, the first one is for the rows, and the next one is for the columns. So when you check this other data frame, you're having 1974 rows, and then the upper one we have 1974 rows. So here's a case now we want to drop the columns in this df for columns, and we also want to drop rows with respect to null values. So where there's a row with the null values will drop, and where there's a column with null values will also drop. So let me run the code. So we'll have 3 data frames. So now we have so now we can see this the first one is having 74 rows. The second one is after dropping the rows we have 1695. So when we come down here now, we are trying to drop columns with the null values, but unfortunately after dropping the rows, so there is no column with null values, so we still have 1695 rows with 10 columns. And because the rows with null values were dropped in this code where we are dropping null values were within the rows. So that's how to deal with the how to handle missing data, and also how to drop rows and columns. So let's talk about how to select a subset of data of the first of the top elements of a given data frame, the bottom elements of a given data frame. So here we'll say first, so let me call this one first n elements of a data frame. So the first n elements will be the first top rows of given data frame, and then the code that we're supposed to use, say df is equal to df dot head, df dot head. Then within the head, now if you don't put any value within this within the brackets after the head function or the head property, you'll get the first 5 rows of the data frame. So let me print df. See, so here I'm going to print the original df, not this other df that we've changed. We've dropped rows and columns. So let me assume that you've understood, and then I will delete this other Python code. I will delete this, and I will also delete this one here. I will remain with df1 and df, but now I want to print df1, not df. So print df. So when I run this code, you'll see what we get. So now you can see we printed the first 5 elements of that data frame, and then supposing we wanted 10 elements, we just come and write there 10, or if you just want 2 elements, the top elements or within that data frame will indicate the value of number of rows that we want. So here I've taken 3, so here we only have 3, the first top 3 rows of the data frame. So when you don't write a number, by default it will pick the first 5, but now let me write 10. So this is what we have as the first 10 rows, that data frame. And again, you can also come down here and say 2, only print 2 elements, 2 rows I mean, of the data frame. That's all about the first n elements. So let's talk about the last n elements of a given data frame. So we want to say last n element of data frame. Okay. So again here we'll say df1 to df1 the tail. So when we print the tail, it means again we are printing the last 5 rows of that data frame. So let me come down here and say print df1. So I will comment out this one. I don't want it to print first 10 elements. So when I run this code now, I can see we are printing the first 5 elements of df, but now I did choose df instead of choosing df1. So let me print. So the last one, so what happens here is that the first one was df1. This one was picking the last was taking 2 elements. So when I print df.tail, because the variable df1 has been changed to just pick the data elements of the first row of that data frame. So what I need to do here, I can write this one df2, because that's why you cannot see any printout down here, because the df, the original df was having quite a number of rows. Then the variable again has changed. Now it is having only 2 rows, which is down here. Then when we come down here, we are printing df.tail, which by default will print 5 rows. And 5 rows we don't have in this df because the variable has changed. So I'll use this one as df1. So this one will be df2. So this will be, so let me say this one is df2, and this other one is also df3. So down here we'll only put df3. as opposed to printing df1. So we have df2 and df3. So let's see what we have for the last row elements of the data frame. So now you can see we have a closing stock of the data frame. So the first one, let me uncomment this one out. Then in between, let me create another space. So print, and to create a space in between. So now the first data frame should give us 2. Now I'm printing df2, not df1. So this will give us 2, then will give us 5. When I run this code again, now you can see the first df, the df2 is giving us rows, and df3 is giving us 5 rows and 10 columns. So that's how to print the last row elements of a given data frame. So let's say maybe right here 1, then I print. So this will give me the last row of a given data frame. So the tailing function will mostly use it when we are doing our Python financial statement automation, because we'll be adding a data frame. Like now, maybe we have indirect expense. We have various categories of direct expenses or various categories of indirect expense. So when we add the indirect expense, we will want to get the total figure of those indirect expense, and within that data frame, we'll also have you'll only pick the last row of the indirect expense, so that we can only pick the total values of those indirect expenses. So this df.tail, the tail function, I will use it quite a lot within financial statements automation. We will stop there again, but I will still come back and continue with some other important functions for data frame before we move on to monthly P&L financial statement automation. So thanks a lot for watching, and please do subscribe if you haven't. And if you have, thanks a lot for your support, and please do share the videos with other colleagues so that we can learn together. So thanks a lot for watching, and let's meet up in the next video.